My name is Bruno Penteado. It's an honor to be here today to present some of the work we are conducting now at Fiocruz to get some feedback, so share some of the insights with you. And it's an honor to close the day, to be the last one to present. And that's it. I think I have some interesting talks here for those who stayed to the end. So this is part of a bigger project funded by Fiocruz through the Estratégia Fiocruz para a Agenda 2030 and the Ministry of Health. And in this case, this specific research here falls under this square of data science and epidemiologic surveillance. But we have another ones. Raquel presented here the platformization, the governance of systems, have the artificial intelligence in healthcare, and we plan to start the new one of generative AI in healthcare in the coming months. So we really are aiming to understand what are the implications of digital health in the public system. So our team here for this specific research is comprised of 7 members. We have very different backgrounds here. Leonardo is anthropologist, Marcelo management, epidemiologist, statistical modeling, public health, and computer science. I am from the computer science background. So we have this very diverse team where we can exchange a lot of information and insights on this topic. So this specific research, we're conducting a scope review on this particular question. How is data science being used in health surveillance, right? We know it's being used. We instinctively know that, but we're trying to reach a formal way to describe that. How is it being applied? So we have these key aspects here, the what for it's being used, the data science, what data sources are being used, and how it's being conducted. And the secondary question that emerged from our research is, what is data science, after all? We discussed previously with Professor Naumar on the concepts of digital health, but what is data science? It's another concept that everybody talks about, but what do we mean by that? So we're trying to understand here how the epidemiologic community is appropriating this concept, how it's operationalized through the research. So we performed a query here in 5 different scientific databases: Scopus, Web of Science, PubMed, BVS, with the focus in Latin America, and Google Scholar, with a very simple query stream here: data science and some major concepts in health surveillance, epidemiology, population surveillance, and the concept of One Health, a more modern concept. And we had these results, a lot of papers, over 1,000 papers from these 5 different databases, where we read read the abstracts and the titles, and our final corpus here was comprised of 123 papers. And some things were very interesting when you read the abstracts. Some excerpts of the text appeared a lot of times, and these 2 ones were the most curious, at least for me. There was a lot of papers named challenges and opportunities. So it was a glimpse of what data science can do in this community. And the second one, the data science approach. I'm going to show you a lot of papers mentions this specific term, the data science approach to something. And this is the word cloud with the outer keywords. We can see some things like machine learning, COVID, electronic health records, big data. A lot of technological terms here present in these papers. So the first question, what is data science? Is it a science after all? What are the ontological, epistemological basis to define it as a science? I've never seen a paper talking about that, arguing, discussing why it should be treated as a science. Is it applied AI, applied statistics? Is a data scientist statistic who lives in New York, who works for a company in the Silicon Valley? Is a fancy name for that. It's not a very accurate concept. And there's a lot of definitions on the internet, most of them from big techs like IBM, or the US Census Bureau. But there's no clear definition of data science. It's a field that mixes together the statistics, the computer science, the domain expertise. So it's something very applied science. And this specific term that merged with the data science approach, there's a lot of papers with this wording. The data science approach for something, as a tool to make something, to make some prediction. And in short, what we discussed that can be considered as data science approach in epidemiology. Data integration, secondary data from many sources and many data structures. Applying AI techniques such as machine learning, deep learning, computer vision, social network analysis. Aiming to predict or identify patterns. And the specific field of research, the epidemiologic surveillance problem. So all of them matched this template of data integration using some AI to predict or identify some hidden patterns in the data. To better understand the phenomena of the epidemiologic surveillance. And we saw lots of increase, the increase of interest in data science. We have this, the data science was used from 2018, it's very recent, but it has this jump here in 2020. And I think you know why that occurred, because of the COVID influence in this year. But what we saw is that it has overflowed to other areas. It jumped, exploded with COVID, the number of papers, but now it's reaching other areas inside this community. It's still very fragmented when you see the bibliometric indicators of these papers. There are some few papers with more than one paper in these journals. Most of them just have one paper for one journal, almost 100 of them. So you have this long tail of venues for publication. You have Nature here, five papers, or Journal of Medical Internet Research, 6 papers, but no more than that. So it's not, there's no single point of publication. And what for is being used? COVID was the main driver, no doubt about that. But there's a big fragmentation for other areas. We have in these 123 papers. More than 1/3 of the papers was related to COVID. But we have some other diseases here like HIV, breast cancer, suicide. But there's a long tail here as well, with very few papers about these other diseases. But overall, we have this respiratory viruses as the main focus because of the COVID, and a lot of chronic diseases like asthma, diabetes. And the second question was, what data sources are being used? We have the traditional ones. We talked about some of them here through the day. The public data sets, such as used in the PCDAS, the notifiable diseases systems, the electronic medical records, but a lot of different data is being used for research. And here in our research, we identified these two new different non-traditional data sources. The use of social media, the text being posted or the connections between people, and the use of mobile devices or the IoT for environmental sensors to capture data. So we have these traditional ones, the epidemiological data, the administrative data, the clinical data, currently being used for decades in epidemiology. But now we see some new sources emerging, such as behavioral data that was very common during the COVID pandemics, where you had to track people trajectory moving between cities or countries. We have this crowdsourcing data where the population can create data, sometimes curated by a health professional, but generated by the people. And this environmental data, where you have this all kinds of contextual data to support the analysis, like the wearables or the other IoT. And the technological contributions here, it's interesting to see the major part, half of the papers, they are just applying state-of-the-art algorithms to the problem from epidemiology. They are not developing new algorithms or something like that. It's just the application of neural networks or extension of the SIR model, SIR model. But it's more the application than the development of new technologies. And another thing that came out from this data from our corpus is that none of the papers mention following a formal methodology to conduct this data science pipeline. But we have found that there is a structure to that. It's a bit derived from previous ones, from other workflows, but they all comprise these 5 steps. Data collection, where you have the data set from those different sources, new methods to collect this data. You have this pre-processing stage to data linkage and formatting. The storage point, this is very problematic in practice because most people tend to store their files, their very sensitive information files on the cloud or USB pen drives, and that can cause some problems for the researcher. The analysis, where the people from epidemiology is very well versed in models to statistical modeling of the disease, but also the dissemination is a critical part for epidemiology to provide recommendations for public policies, to develop some instructional material, or even develop a new software. And in our corpus, most part was here, the analysis part. Most contributions were in modeling the disease. And in the end of past year, we did this workshop with 30 practitioners from the public health system, where we tried to understand what were their concerns regarding the data science. And almost all of them were listed these three aspects as their main concerns. The data quality, they complain a lot about missing information from the national information systems, data integration from these various data sources, and data security. How can they use their patients' records in a secure manner? So in our research, these are the new next steps. We are defining a model process to support these practitioners in how to conduct this data science workflow. And next year, we want to apply this multiple case study with some successful cases, such as the Penteado, to understand how they operationalize this workflow, how they make these things concrete. And in the end, to give back to the community, to these practitioners here, how they can better develop their work, their research using these new approaches. So to summarize here, the key takeaways, data science here can be considered as a quantitative approach to data analysis. It's very new to epidemiological surveillance for now. This concept of data science, of course. And there is this exploration of new data sources which are more timely or good enough to provide some insights. You have those information systems from the government, but they are usually 1 year, 2 years ago. Now we can have some data from Facebook or another social media that's real time. So sometimes this can help a lot in some situations, some kind of outbursts. From COVID to other areas, applying AI techniques, but without a formal process. So this is what we found from our leading question. Donc, voilà, merci.